The fibrous tissue between the atria and ventricles is a perfect insulator. It lets the passage of electrical activity from the atria to the ventricles at only one point, and this is the atrioventricular node. The conduction is delayed in the atrioventricular node. This delay helps the ventricular depolarization to start sometime after the atrial depolarization ends. Ventricular depolarization takes place in more than one step because the ventricle is made of a bigger muscle mass. And these depolarization steps are reflected on the electrocardiography recording as more than one wave. The group of waves representing the depolarization of the ventricles is called a QRS complex. The first part of the ventricles that is going to depolarize is the septum. Depolarization of the septum starts at the left part of the septum. The cells in this area become negatively charged on the outside, and this is going to form a dipole at the septum. You can see that there can be many dipoles, but if we take a summation vector for all of these dipoles, we are going to see that our vector will be showing the right side. The tip of the vector, the positive end of the dipole, is going to be on the right side of the heart. How will this dipole reflect to our D2 electrode? We can see that our positive electrode is on the negative side of the dipole, so electrocardiography is going to record a negative wave. The first negative wave in the QRS complex is called a Q wave. So the Q wave here in D2 is representing the septum. It is a small wave because it is representing a relatively small muscle mass. When the muscle mass is bigger, it is able to produce a bigger dipole. So septum is a small muscle mass, it produces a small dipole and therefore is reflected by a small wave on the electrocardiography. The depolarization from the septum moves towards the apex, and the dipoles that are formed there are believed to be represented in the first wave together with the septum. The next part of the ventricles that are going to depolarize are the walls of the ventricles. The depolarization spreads by the His bundle branches to the endocardial surface of both of the ventricles. And from the endocardial surface, depolarization is going to start at the subendocardial myocardium, and it will spread towards the subepicardial myocardium, or shortly, depolarization will spread from endocardium towards epicardium. And the dipoles formed by this spread of depolarization can be represented by vectors that are pointing towards the left side. Obviously, the dipoles that are formed by the spread of depolarization from endocardium to epicardium on the right ventricle, they are going to be pointing towards the right side of the heart. You must have noticed that the vectors that I have drawn for the dipoles on the left ventricle are longer and they are shorter on the right side. This is because the wall of the left ventricle is thicker, and therefore the greater muscle mass there can produce bigger dipoles. The thickness of the right ventricle wall is approximately 3-4 millimeters, and the thickness of the left ventricular wall is approximately 8 to 10 millimeters. So we have many dipoles pointing in many directions. If we take a summation vector for all of these vectors and dipoles, it is going to point towards the left side because of the predominance of the left ventricular muscle mass. So here is the vector representing the depolarization of the large areas of the ventricular walls. The positive end of the dipole is on the left side and it is close to our positive D2 electrode. This is going to result in the formation of a positive wave in electrocardiography. The first positive wave in the QRS complex is called an R wave. This R wave in D2 is big because it is representing a large muscle mass. The last part of the ventricles that are going to depolarize are the upper parts of the septum and the posterobasal parts of the ventricles, especially the left ventricle. I want to open a parenthesis here to remind you about an anatomic name. So, the base of the heart is not the place where it sits on the diaphragm. That part of the heart is the inferior part of it. Basal part of the heart is in the opposite direction to the apex. It is where the large vessels are coming out of the heart. So, if I can place for you the depolarization vector for the upper part of the septum and the posterobasal part of the left ventricle. You can easily see that the negative end of this vector is close to our positive electrode. So these parts of the heart and the depolarization in these parts of the heart are going to be represented by a negative wave, and this is going to be a small wave because the muscle mass that we are talking about here is a smaller muscle mass. The first negative wave after positive wave in the QRS complex is called an S wave. So the S wave in D2 is representing the depolarization in the upper parts of the septum and posterobasal parts of the left ventricle. Before finishing, I need to talk about the names of these waves. The first negative wave in the QRS complex is a Q. The first positive wave in the QRS complex is an R. The first negative wave after the R wave is an S wave. The second positive wave in the QRS complex is an R prime, and the second negative wave after a positive wave is an S prime. I need to explain that the waves are given names according to the place that they are located in the QRS complex. What I'm trying to say is that septum may be represented by Q here, but it doesn't mean that Q always represents the septum. We are going to learn later on in the following videos that in some leads of electrocardiography, an R wave can represent the septum. And if we talk about the summated vector of the QRS complex, or in other words, the depolarization of the ventricles, it is approximately at plus 60 degrees. Towards the left side, it has a limit until minus 30, and towards the right side, it has a limit until plus 105 degrees. After all cells in the ventricles are depolarized, or in other words, when they are at the plateau phase, the outer surfaces of all of the cells in the ventricles are negatively charged. There is no longer a dipole in the ventricles, and after the QRS complex, we are going to have what is called an ST segment. An ST segment is also an isoelectric line. It begins at the end of QRS complex and ends at the beginning of the T wave. So we have talked about the depolarization, the spread of depolarization in the heart and the atria and in the ventricles, and the electrocardiography waves formed by this. Thank you for watching.